Alright, so today I get to introduce to you guys about matrix. You guys probably heard of matrix before in Algebra 2, where you see these brackets and then there's usually numbers inside the matrix. And for plural, so matrix is singular for one matrix. Matrices is for plural, multiple matrices. So in this case here, I want to go over just how we define a matrix, and generally we look at the dimension first. So we look at rows and columns. So when we name a matrix, we always say the row first, and then the columns. One way you can remember that you have to write rows and then columns is to remember race car. Or I like to remember Rice Krispie. Whatever works for you. But remember that it's always rows and then columns. So using this as our example here, this has 1, 2, 3 rows because rows are always horizontal. So 3 rows. And when we look at the columns, that's how the numbers are stacked vertically. So 1, 2, there are 2 columns here. 2 columns. So we call this matrix a 3 by 2. So that X here, we just call it a by. We just pronounce it as by. So a 3 by 2 for this case, because you always say rows then columns. Alright, so if you're feeling pretty good about naming or referring to the dimension of this matrix, let's practice this skill in the next slide. Okay, so in this slide here, let's talk about the size of these matrices. One of the things that helps me here to figure out how many rows there are and how many columns is to draw a grid. So this is what I mean. I noticed that there are two rows of numbers. So I'm going to draw a grid like this to divide them, and then I'm going to divide these into columns. And so when I see this, I can definitely see that there are 2 rows, and in this case, we have a 2. And then there are 3 columns. So this is a 2 by 3 because we always say rows and then column or race car. This next one's a little tricky. Notice how there are only like 2 numbers stacked each other. Well, if you divide them, notice how there are actually 2 rows. So there are 2 rows, but there's only 1 vertical stack, which tells me this is only 1 column. So this is a 2 by 1. Also, I don't think I mentioned this in the last slide, but that X right there also is like a multiplication symbol, which tells you how many elements are inside the matrix. So notice 2 times 3. 2 times 3 is 6. There are 6 different numbers in here. Whereas 2 times 1 is 2, and you have 2 numbers in here. And then this one only has 1 number, because in this case, this is 1 row, 1 column. So this is a 1 by 1 because there's only 1 number here. So it only can be 1 row and then 1 number. So it only can be 1 column. So it's a 1 by 1. And in this case, 1 times 1 is 1 element. So this works. All right. So if you got your dimensions down, let's go ahead and do some adding and subtracting with matrices in the next slide. By the way, I don't know if you've noticed, but I put an optional homework up above on each slide that is recommended for practice in the textbook. So going into adding and subtracting, one of the important things you need to know is that they have to be the same dimensions in order to add or subtract. If the size is not the same, then you cannot add them or subtract them. In this case, they become undefined, and you just stop right there and just say they're undefined. And then when you add and subtract, fairly easy. All you're going to do is take the corresponding number where it's located and add it or subtract it to the corresponding number that's in the same spot that it's in. So let's use 15 here as an example. Now 15, notice how there are 2 rows. So this is a 2 by. There are 1, 2, 3 columns. So this is a 2 by 3. This one is also a 2 by 3, I noticed. So if they're both 2 by 3s, lucky for me, I can add them. So when I add them, all I'm going to do is really just add the corresponding numbers together. And I should produce another 2 by 3 when I do this. So like I said, I'm going to take the same number and add it to the same number in the same location. So 6 plus negative 8 is negative 2. Negative 9 added with 2 gives me negative 7. 2 plus 7 is, sorry, I meant 2 plus 5 is 7. And in the bottom row, 4 plus 6 is 10. 1 plus negative 3 is negative 2. And 3 plus 4 is 7. Lots of 7s here. But that would be my final answer. And like I said, I just took the number that's in the same location with the other matrix and added them together since this was an addition sign. The next one here looks like you have 2 rows. 1, 2. So this is 2 rows. And then it looks like there are 2 columns. 1, 2. So 2 columns. So this is a 2 by 2. And so is the other one. It's also a 2 by 2. So that means that you can subtract them. Since there's a subtraction sign here. Now with this one here, I want to show all my work, whereas this one I didn't really show much of work, but this one I am, just because I want you to see the sign switch. So again, this will be a 2 by 2 since they're both all 2 by 2s. So when you look at this problem here, you're going to take the first number and subtract it with the other number that's corresponding. So that's negative 6 minus 0. For the first number here. You're going to take the 8 and subtract it with the 0, so 8 minus 0 goes over here. And then you can take the 0, subtract it with the negative 4, so that's 0 minus negative 4. Notice how there are 2 negatives here. And then this is 0 minus negative 2, so that's 2 negatives as well. And then when I simplify this, the reason why I show all my work is because sometimes if I don't, I might forget that there are 2 negatives here. So this is just to be extra careful so you can change those negatives into positives. But the first one here, negative 6 minus 0, is just negative 6. The second one is just 8. The third one is just 4, and 0 plus 2 is just 2. And there we go. We have our 2 by 2 matrix. So that would be my final answer here. All right, and then number 21, you can see that this one here has 2 elements. So it looks like there's 1, 2 rows. And you can see there's only 1 vertical line of numbers. So this is a 1 column or a 2 by 1. This one only has 1 row because there's only 1 horizontal line here of numbers. So 1 times or 1 by, let's see, there are 1, 2 columns. So this is a 1 by 2. Notice how the size is not the same. So because they are not the same size, you cannot add the 2 matrix. In other words, this will lead to an undefined matrix because you cannot add them. So that's it. So basically, rule of thumb, you need to check the size to make sure that they are both the same size before you can add or subtract. You always add or subtract the corresponding located elements. And then if the size is not the same, then it's undefined. All right, let's go into our next topic here, which is something called a scalar. Okay, a scalar is a number that is multiplied to all elements inside a matrix. So this is multiply. Sorry, my phone is going off. Let me turn that off. There we go. And I spelled multiplied wrong. Multiplied. That is multiplied to all elements inside a matrix. So, like with number 23 here, you can see this is 2A or 2 times A. So it's saying that this 2 is outside the matrix A. So A is a matrix. Looks like a 2 by 2 matrix. Oops. So I'm going to draw the 2 by 2 matrix here. So negative 2, 4, 0, 3. And then I'm going to distribute this 2 inside because this 2 is a scalar. It multiplies to all the elements that's inside to the matrix. So you can think of the matrix as being this very big parentheses, and then the 2 being the coefficient or the constant that's outside that needs to distribute to every number inside the matrix. So once I distribute, I get, well, 2 times negative 2, negative 4. 2 times 4, 8. 2 times 0, 0. And 2 times 3 is 6. And then there we go. That's our new matrix. And so The other one here, just a -3 in front of b, so I'm taking -3, multiplying it by b. So this would lead me to -3, grab my b matrix, which is -6, 2, 4, 0. And I'm going to distribute this 3 in. I'll write it down here. So notice how when I multiply by a scalar, I don't change the size of the matrix. All I do is change the magnitude of the numbers inside. So in this case, everything in here gets tripled and basically change the sign. So -3 times -6, positive 18. -3 times 2, -6. -3 times 4, -12. -3 times 0, 0. And then there we go. We have our new matrix here. 25 is a little bit tricky. This one has a few things here, a combination of things. You have to multiply 2 with A, and then you have to subtract it with B. So kind of like what you're doing here is like a set of order of operations. So first let's set this up so we can visualize what this is asking us to do. So this is 2 times our A. A is -2, 4, 0, 3. Minus our B, which is -6, 2, 4, 0. And so what I'm going to do first is I'm going to multiply the 2 first into matrix A. The reason why is because like in order of operation, typically you want to do your multiplication before you do your subtraction, right? So in this case, I'm going to multiply the 2 in to get -4, 2 times 8 is, 2 times 4 is 8, so that's an 8. And then 2 times 0 is 0, 2 times 3 is 6. And then I'll bring down the other matrix. Nothing about it has changed, I just brought it down. So now I get to take my matrix A and my matrix B and subtract them. So when I do this, they just need to be the same size, and they are the same size. They're both a 2 by 2. So I'm going to take this matrix, subtract it with the element that's corresponding to it. So -4 minus -6, that becomes a positive, so that becomes a positive 2. -4 plus 6 is a positive 2. I can't talk today. 8 minus 2. 8 minus 2 is a 6. 6 goes in. 0 minus 4. 0 minus 4 is -4. And then last but not least, 6 minus 0. 6 minus 0 is 6. And then that's our new matrix. So that's my final answer. Alrighty here. So if you're feeling pretty good, I want you to try out the exit ticket here in the next slide. So here it is. You are given those two matrices, an A and a B, and you are asked to find -2 times A plus 4 times B, and so you should have one matrix in the end after you do your operations. Alright, I hope this video was helpful. Try to use the video if you're having trouble with these problems and see if the past problems help you out as an example. Alright, see you next time, guys. Bye.